Okay, so the angle inequality property, basically, I when I first saw this, I didn't know what the big deal was. All right, because to me it was very logical, and there was really no reason for this to be stated, but they make a big deal about it for some strange reason. First of all, let's go back to this picture right here. What does angle 1 equal? Exactly. That's how easy this is. We already know that angle 1 is equal to angle 4 plus angle 3. Everybody agree with that? All right, we proved that. That was an easy proof. All right. So guess what? The exterior angle inequality theorem says, fancy words. All right, it just basically says angle 1 is an exterior angle. That's greater than angle 3. It says angle 1 is greater than what other angle? 4. That's the exterior angle inequality theorem. Now, how do we know that's true? Because the whole is greater than the what? The parts. All right, the whole is greater than the parts. Like I said, this whole chapter is just about rules for the triangles. Rules about sides, rules about angles. All right, it's very logical and very simple. I think section 5.2 was the hardest section, all right, that we did yesterday and the day before. All right, we finished that up. So again, the exterior angle inequality theorem just simply says that the exterior angle is greater than the remote interior angles. Simple as that. So now we just look at a bunch of pictures and you just have to tell me what angles are greater or what angles are less. All right, so let's start with number 1 here. What angle? Oh, I didn't say this, but is there ever a relationship between angle 1 and 2? It's just what? It's just supplementary. But is one greater than the other? Not always. Right? Could be 90-degree angle, that's true. All right, it could be angle 1 could be obtuse, or angle 1 could be what? Just like this question right here. This exterior angle and this exterior angle are completely different. All right, there is no relationship other than that the two angles always add up to 180. All right, is everybody okay with that now? All right, very simple. I didn't say that. I should have. All right, because that will help you down here. All right, so James, you can start us off. Again, the idea is let's just get through this. All right, so we have no homework. Take a break. All right, James, tell me about the measures that are less than angle 1.
Angle 3 and angle 4.
Angle 3 and angle 4. All right, we'll just continue. Harrison, number 2. Angle 5. Is that it? And angle 1. Now, as soon as you don't know something, just speak up, okay? I think it's easy, but if you don't see it, right, until you see it, it's not easy. Anybody have any questions? What?
Why isn't 2 greater?
Why isn't 2 greater? Because I don't know what angle 2 is.
Oh.
You see what I mean? There is no relationship. All right, the relationship is the exterior angle. Here's the only thing you know. The exterior angle is greater than the remote interiors. That is the only thing we know.
Okay.
If it's not an exterior angle, you can't relate it to anything other than the remote interiors. Just like angle 5. Angle 5 is related to what? 2 and 3. That's the relationship.
Okay.
All right, you can only compare 5 with 2 and 3 and 1 with 2 and 3. That's it. That's really simple. That's all there is to it. All right. You can't talk about 1 and 2. You can't talk about 2 and 4. You can't talk about 2 and 3. All right, Jackson, you're up. If no one else has any questions.
Metrics that are less than angle 1, so angle 5 and 6.
Wait a minute. Oh, yeah. Thank you, sir. I'm not even paying attention. Right. 1 and 2. That's for here. Thank you for reading. I did not. So say that again because I was confused.
Angles 5 and 6.
5 and 6. Yep, because we're going down there. All right. Is there anything else we can know from that? Okay, good. All right, Lucas, you're up.
Measures that are greater than measure 1, number 7.
Yeah, I just think that's angle 7. And if you think it's something different, I can totally be overlooking something. All right. I could totally be overlooking something. So you think it's something different, just let me jump in. You might be right. All right. You might be right. Now, again, what's the problem here? There's just overlapping triangles, correct? So you just have to be careful with what you're looking at. Anybody have any problems? All right, Olivia, tell me about the next one.
Angle 1 and 3.
Angle 1, angle 3. I like that. Anybody else? See anything different? Come on, don't be afraid. What else? Tell me.
Okay, 5 and 6.
Yeah, I say angle 5 and angle 6 also. Do you agree with that?
Yes.
Right. Because 7 is here. Now, does everybody agree that 3 plus 5 and 6 are the remote interior? Does everybody agree with that? Yes? All right, I think that's good. Now, I think it's a technicality, but I think you should tell me that angle what? TUV, right? Everybody agree? Even though we said angle 3, angle 5. Does everybody agree with that? Bless you, bless you, bless you, bless you. Yes.
Could we also say angle 4 because angle 7 is on 2, so angle 2.
What if I wrote it this way? You with me? Everybody thinks that. All right, everybody thinks that. So you have to understand that is just a drawing. I could very well just go ahead and, and again, this is important, remember, because it's not, I could draw that way over here and it'd be the same thing. W. Nothing would change, correct? You with me? Just because it looks obtuse doesn't make it obtuse. So just because it looks right doesn't make it right. All right, that's what makes it tricky. All right, that's what makes it tricky. All right. So where am I at? Who's up for 6? Jackson, did you do one yet?
Yeah.
Harrison, are you up? Did you already do one?
Yeah.
Wow, am I just going crazy? All right. Did you do one, Olivia?
Mhm.
Wow. All right, Nate. Tell me, must be on number 6.
I don't understand. Can you help me with this one?
I'm not gonna help you, but we'll look at this. So highlight it so you can see it better. Now remember, what I always try to tell kids is look for is that an exterior angle? So it must be a remote interior. So if that's a remote interior, then what's its exterior angle? Nope, 7 would be its supplement. Yes. You with me now, right?
Yeah.
And why is that annoying? It's annoying because on your test, if you want, you could wipe this out and you can totally see it now, correct?
Yeah.
Right, it's just the overlapping lines that cause problems. Yes,
I thought you said you could only like use the exterior.
I don't know what you're talking about. What did you just say? I can only use the exterior angles. I don't even know what that means.
Like on the image of profile, when we asked what can you say that angle 2 was greater than measure 3, and you said we can probably kill the exterior.
Look at angle 2. What's the exterior angle for 2? What? Right? All right, here we go. Go.
What's the number 6? Is it 5?
Okay, so I have angle 4 written down. Okay, because and again, I think I understand the problem. I want you to get rid of this line right here. That has nothing to do with angle 2, right? You see what I'm saying? So 4 now is an exterior angle. Kids don't understand that because they look at that and say, what are you talking about? It's on the inside. You with me? But because that UV is drawn, it appears as though it's an interior angle, but it's not really. Okay. Right, Maren? That good? Okay. So let's look at question 7. Let's bring Michaela, go. Hold on, let me erase this. I gotta find 5. Okay. Measures that are greater than angle 5, what?
Angle 1 and angle 7.
That's exactly right, I think. Anybody else come up with something different? Angle 1 and angle 7. And again, try to write the answer, all right, before the person says it. You can see if you know it. Is everybody good with that? Okay, Maren. Easy as that, kiddo. Angle 2 and angle 3. Anybody else? 4, angle 2 and angle 3. Yeah, that's the only thing I see. Anybody else? All right, Elise, measures that are less than angle 1.
Angle 7 and angle 5.
7 is greater than angle 1. Oh, thank you, thank you. No, I'm on the wrong one again because I don't pay attention. All right, here we go. So these two are over here. Sorry. Measures that are less than angle 1. Tell me again.
Angle 7 and angle 5.
And you're correct. So this one, and I think this one is on the test actually. This one, and what else? Yeah, that's a trick question, right? Because angle 4 and angle 5 are what? Angle NPO. Tell me.
Why wouldn't angle 6 be?
Why wouldn't angle 6? Okay. So let me highlight angle 1, see if I can explain this. Here is angle 1. I don't think we can talk about angle 6 because it's not an interior angle to that. Right? So angle 1, I'm going to try to draw this better. So if I'm looking this way and I'm looking this way, right? 6, I can't really, because watch this. If I draw, and this is what I was trying to show Harrison, if I draw it higher, right? It could be less than. Do you agree? And if I draw it lower, it's definitely what? Greater than. You see that? Right. Okay. So again, I think the trick question there is, like I said, I think that was very good. We said angle 7, angle 5, angle 4, and then angle what? NPO. All right. Yes.
The measures are greater than measure of angle 4 would be angle 1 and angle 8.
Oh, are you doing this one? Okay. Hold on one second. Let me erase. I thought you were asking me a question. So measures greater than angle 4. Tell me what is greater than angle 4?
Angle 8.
Wow, that's really good, girl. I didn't even see that. Look up here. Look what she did. That was pretty good. So angle 8 is greater than this angle, right? And therefore it must be greater than angle 4. That was good. Angle 8. What else?
Angle like 2, 2.
No, I don't like that one.
Angle 1.
Definitely angle 1, right? Do you see that?
Yeah, that's what I said.
Oh. Oh, okay. I'm sorry. I didn't hear that. I'm daydreaming today. Angle 1. Okay, so this right here is greater than 4 and 5, so it must be greater than 4. Right, and the same thing with angle 8. Angle 8 is greater than 4 and 5. Yeah. Is there anything?
If angle 1's greater than 4, then technically on number 9 couldn't and couldn't 6 also be 1 on number 9 because
Okay, that's what I'm asking. Yeah, that's what James said.
I know, but now that
Okay, but what I'm saying is, okay, so I can see, this is what I'm trying to tell you. I can see 4 and 5 make up the remote interior, correct?
Mhm.
But angle 6 is not part of any remote interior.
okay, thank you.
You with me? All right, and I tried to make an example by drawing that higher and lower. All right, does everybody agree? That's not so bad. Go, tell me. Number 7. What's wrong with that one? So this is angle 5, right? So what's an exterior angle to that? Yep. And what else?
I don't know what that one is.
Because you're looking at UT, cover up UT. If I block UT, now it's an exterior angle. Right? All right, so I'm pretty happy with that. Okay, now again, super duper easy. All right. And we can make a quick little demonstration of this. Look right here. All right, let me show you something. All right, which again, once my teacher showed me this, it was just so simple. I'm creating an angle. Watch. Now I'm trying to keep the two sides of my angles the same. All right, I wish I had the ability to leave it there, but I don't. So as I increase the angle, do the sides change of the angle? No. I'm trying my best to show you that I'm not changing the side by opening it up. You agree with that? Only the angle is changing. All right. Because only the angle is changing. All right. If I were to draw this triangle, come on now, watch how simple this is. If I were to draw this triangle,
Just use the like lasso for the clip on.
yeah, thank you. Here, as I'm going this direction, does everybody agree with me? As I open the angle, what side is changing? This is changing. Right? The wider I open the angle, the greater the opposite side. Does everybody agree with that? Does that make sense? All right. The other thing that helped me out on this was if I have an equal angular triangle, what's true about all the sides? They're equal, right? So if the angles are equal, the sides are equal. If the angles are different, then what? The sides are different. All right. Now, how do you know which is the largest side? Right? If I draw, for example, an obtuse triangle, which one is the largest side?
Like top one.
Yeah, but how do you call that? What's that top called? Right? Because look right here. Now it's not the top. Right? So what I'm trying to show you, and this is the important part right here. So listen, the side is always related to the opposite angle. This angle determines this side. Does that make sense to everybody? The bigger I open that angle, the bigger the opposite side becomes. Right? Does everybody see that? All right. So if I told you this was, let's say 70, this was 50, and this was 60, what's the largest side? Name it by color. The purple one. Does everybody agree? Come on, it's so simple. I couldn't believe I was actually doing this. No one had to tell me that. All right, then the smallest side would be the what?
Blue.
The what?
Blue.
The blue. Does everybody agree? And then the middle side would be what? The red. All right. So this is the smallest angle. It's opposite the smallest side. The largest angle is always opposite the what? Largest side. And like I said, I personally feel like this chapter is just all common sense to me. No one had to teach me that. I didn't have to have a proof for that. You just look at it and tell me that. Especially when you think of a what? An equilateral triangle. Or when you think of an isosceles triangle. The hypotenuse is always the largest side. Why is it the largest side? Because it's opposite the largest angle. All right. Anybody have any issues with that? All right. So with that being said, let's just go to number 11. I don't care about the examples. List the angles. All right, here we go, guys. Tell me the angles from small to large. Angle T, then angle R, then angle S. Anybody have any issues? All right. So, Catherine, you get to tell me smallest to largest for 12. Wait a minute. Sorry. Obviously, we're doing sides now. Good.
RT and then ST. Oh, wait, no, ST then RT.
Yes. Right now, here's something else that a lot of people listen to what I'm saying, everybody. I don't even have to think about drawing the side. If I say angle R, then the side opposite angle R is what? The other two letters that you didn't say. Right? Does that make sense, guys? I mean, I don't have to look at it, right? If I talk to you about triangle ABC, and I say what side is opposite angle A, everybody agree that it should be, you shouldn't have to think about it. You shouldn't have to draw it. You should just be able to tell me it's what? BC. If I say what's opposite angle B, you should say what? If I say what's opposite angle C, you should be able to tell me it's AB. Everybody okay with that? All right. It's to me, it's a little easier now, right? Because I just name the angle and then I just write the other two letters. Does that make sense, everybody? All right. Hopefully that makes sense. All right. So now you have a problem where they give you the sides, you name the angles, they give you the angles, they name the sides. Elise, is that okay?
Yeah.
All right. Did you do one yet? Did I skip you? All right. You're on 13. Go. Name the angles. So what's the smallest side, kiddo? Right. So you said AB. So what's the angle? What's the other letter that's not mentioned? There you go. That's all. So now what's the other middle angle? So it'd be angle B. Then what? All right. Hopefully everybody understands what I'm saying. That's how I would name them. Right. To me, I would just say, okay, AB is the smallest side, so C is the smallest angle. All right, Chloe, you're up. Help me with 14. Angle S, angle U, angle T. Perfect. All right, Lexi, you're doing angles too.
Angle B,
Angle B,
angle C,
angle C,
angle A.
angle A. Super easy. Will, go.
Angle Q, angle P, and angle R.
Everybody okay with that? All right, Pancholi, go.
Side DC, side DE, then C.
And you know, it's kind of funny on the test, bless you. Bless you. On the test, I mean, I don't, you just name those, right? If you can't tell me which one's the largest, you agree we're in a little bit of trouble here, right? You don't need a theorem is what I'm trying to say to tell you that. All right. All right, James, finish this off.
YZ, XY, and XZ.
Why is that? How do I know that?
Because it's all the angles have to add up to 180.
Right. Yes. So that's 64. Okay. So tell me again now.
YZ,
Good.
XY, and XZ.
Yeah. I totally think that's easy. All right. What I want to do is go down here to 23, 24, 25, 26. Let's see if there's anything hard here. Let's actually start here. Oh, it's kind of funny. All right, this is supposed to be 19. All right, here we go. So let's find QRW. And let's find RWQ. I don't care about those. Those are easy. Links to the given sides, DH. and GH. Yeah, there's nothing hard here. Those are easy. I thought there might be something tricky at the end. All right, it's so obvious, in my opinion. All right, so what time is it? 50. We have about 15 minutes, right? Yeah, I think we can finish this. All right, try this. 15 minutes. All right, just get it done. All right, 1 through 27. All right, and we're trying not to have homework, so just get it done. All right, get it done, get it done, get it done. And if you're not sure, you can ask me.